on how to troubleshoot the network. So we can go to the agenda. So there are a few topics that we're going to speak. So as I mentioned, FTTH technology options. We will touch briefly on WDM overview. And this is also good to know because we will see how FTTH is migrating more and more for a WDM approach. The next generation PON, which is a junction, and how we can troubleshoot our FTTH network using the correct test instrument. We will do a small demo of one of the products that we launched recently, which is the Optical Explorer, which is part of the optical fiber multimeters category. And we will touch the IOLM, and we will see how we can use multiple instruments to troubleshoot a real case scenario that happens every day on our network. If you have any questions, please feel free to ask, even if I have to stop, and then we can continue, and perhaps we'll have more people with the same question in the audience. Okay, so when we look into the technologies options that we have implemented on our networks and that we've seen implemented on the networks from the operators, we always talk about two types of networks: point-to-point and point-to-multipoint. So there are a few differences between them. I will start by describing the point-to-point network. So on the point-to-point network, we will have what we call aggregation node. So the aggregation node can be basically just an Ethernet switch that is placed much more close to the customer premises. So we're not talking about 10, 20 kilometers. We're talking to distance which are much smaller. And we have a direct line. So we have one wavelength going to the customer house, one wavelength coming from the customer house to the node. We have as well, so the advantage of the point-to-point is, without any doubts, the possibility of giving higher data rates, high data transfer between the aggregation node and the customer house. And normally, we will have a direct fiber, so there is no optical splitters in between these two locations. So on the other hand, and here on the bottom, we have the point-to-point, point-to-multipoint networks. So on the point-to-multipoint networks, we don't talk anymore about aggregation nodes. We're talking about now about optical line terminal, which is the name, the designation given to the concentrator, which will spread the signal on the fiber. We start seeing now optical splitters. Passive components, which split the level of light, the power, into different fibers. And just for you to have, so the splitter ratio would change, and the maximum can be 1/64 or 1/128. So we've seen most common 1/64. And if you have an idea, and this is the rule of thumb, if you have 50% of the power, which is 1/2. So if I have one fiber coming in and two fibers going out, this equals to 50% of the power for both of the legs, which is minus 3 dB, the incoming power per fiber. So if you're going to go for 1/64, we can keep dividing by 50% until we find the relation. So this is one of the takeaways that I would like you to take today, just as a rule of thumb. Difference between point-to-multipoint to the point-to-point network. We have, in terms of data transfer, we will have a downstream, which is a broadcast. So here we will start with this segment of data where we have 1, 2, 3. So they will be spread by the three elements for the three subscribers on the network. And then each one of them will have a slot which cannot collide. So it's going to be a timestamp related transfer back into the optical line terminal. So if the ONT, which is the node that stays on the customer house, doesn't receive the communication and the time to speak slot from the OLT, it will never communicate back to the OLT. So, and we will see how important this is, especially when we are trying to measure with the power meter our loss on our network. So what is the advantage? Other advantage that we have on the point to multipoint, because we have less fibers, we don't occupy as much space. Our OLT will be 10 kilometers up to 20 kilometers away from the optical network terminals, so I don't need a massive cabinet on the road. And because I have less fibers, I have a smaller duct size. So it's just I could save on the ductwork. So looking into other point-to-point networks, and specifically on the WDM networks, because most of our core, most of our backbone that fits the OLTs are WDM or WDM networks. In this case, we can have two sets of WDM. I will just explain them in a few seconds. But the difference on WDM is that you have different wavelengths, and those wavelengths are associated to units which stays on the racks, which are called transponders or tributaries. If you want to look for the SDH networks, and then you would have one wavelength, second, third, and fourth. Those fourth wavelengths will be combined in the MUX. On the output of the MUX, you would have one single fiber, which will carry all the four wavelengths. And then on the receive side, you would have a unit called a DMUX, which will do exactly the opposite as the MUX does. These elements can be passive as well, and it will feed back to the transponders, back to the receive side of the transponder, the communication. And this also means that if you would have the second segment where this side, the B side, transmits to the A side, you would need to use a separate fiber. So one fiber for the up and one fiber for the downlink. Why is this so important? This is important for massive data rates, and if you want to use the full bandwidth of the fiber, and this is what we start seeing now. So if you're going to the CWDM, we will see that it occupies from not only one window, but it will occupy 5 windows. So it will occupy the O band, E band, S band, C, and L band. And this is what the spectrum will look like. So we're going to go from 1470 nanometers up to 1610 nanometers in CWDM, and we would have a spacing between channels of 20. On the DWDM, so the DWDM is just a small slice of the CWDM, and it will go from 1553 to 1547. What is the difference between the CWDM and the DWDM? So the C stands for coarse, so you would have a little bit more space, and the D will stand for dense. So that's where, so the name is directly related with the spacing between channels. So just for you to give you an idea, just in terms of troubleshooting of DWDM and WDM networks, there are, because the spacing and the channels are specified by the ITU-T, these channels can be verified using, for example, an instrument called optical channel checker, which gives you the indication that on the same fiber you can measure all these different powers that you can see here on the screen. So what happens if now people start merging FTTH, specifically the point-to-multipoint, with WDM? So this is something that will happen in the next coming years. And this again will be related with the fact that people will need to utilize the full bandwidth of the fiber. So what you see here today, if you look into the splice and the spectrum, most of you will be working on GPON or 10 gig GS PON, which is 10 gig symmetric PON. And these will be sent to the network, sent through the splitters, and then the customer will be fitted with GPON signals or 10 gig GPON signals. But tomorrow, with the new generation PON, what you're going to have is a move from the WDM concept into the PON, where you are going to have up to 8, 9 wavelengths. For the new generation PON, you may have. And these wavelengths will be introduced on the MUX unit, and then from the MUX unit it will go for the coexistent element, a combiner, and all these wavelengths, they will be injected on the fiber. So what is the benefit of this? Well, in first instance, the benefit is that I will remain with the same subscribers that pay the same price at the same data rate. Then I would have companies building where I have multiple people, thousands of people working, and I will also be able to feed even bigger enterprises with using the same concept of GPON and splitter passive optical network architecture. So there are already some trials with the new next generation PON and some networks already built around the world. Today, I would say in Europe, the XGS PON is the one that is coming to the market, and the new generation PON will come just after that. So I have here a few data rates related with the data rates and with the different legacy and current implementations. So let's start on the GPON one. So the GPON will be data rates of down and up of 2.5 and 1.25 gig. EPON, which is associated with the point-to-point architecture, we would have 1.25 gig. Here we're not talking about shared, so it's going to be customer, subscriber, maximum. And then we have the 10 gig, as I mentioned, 10 gig symmetric. So you may have this implementation on the same fiber. You may coexist 10 gig for customers plus 2.5 gig upgrade upload. And then we may have customers, company, enterprises using 10 gig symmetric, where the upload is really important. And then we have these new generations PONs where we can have the same implementations, 10 gig, 1.25, and you can see as well exactly the WDM spectrum. You can associate this slice here with the concept of the WDM that I just talked about. So you have new generation PON 2 and new generation PON 2 as well. So up and down. In terms of implementation, we would have different wavelengths. So we know you are familiar with the 1490 for the GPON. You will start seeing, and 1310 for the upload, you will start seeing the coexistence of the 10 gig. First of all, so 1577, which is just in between, and 1270. So these ones you will start seeing much sooner than the other ones. But the other ones will come and will follow just right after. Just in terms of another concept that you may be wondering is, why do we use, for example, 1310 lasers and 1550 lasers around this spectrum and not other wavelengths? So essentially, because the lasers at 1310 and 1550, they are relatively cheaper to manufacture. And this is also one of the factors where you see all the implementations taking in account how much would that cost to implement. So just a small add-on on here. So we get to the point where we should ask ourselves, looking into this PON architecture where we have multiple technologies. So we have a GPON customer, we have a 10 gig GPON symmetric customer. We have even a 5G antenna, which is fed by a 10 gig PON implementation. We have our splitter, we have our CO. And the question that I want to make you here is, what equipment should I use to troubleshoot my network? So if I have a break here, which equipment should I use? If I have a break before the splitter, which equipment? If my customer is saying that he has light coming into his ONT, but he doesn't have Ethernet signal, what can I do? How can I assist him and promptly resolve the fault? I have a high latency, or I have a very weak signal on my 5G cell. how can I troubleshoot that? So I have here a few products which I will mention today. The first one I will start by showing here. So it's the Optical Explorer one. It's our optical fiber multimeter. Not only measures the power, but also measures, so it can also detect link losses, can also detect, see where the link has faults. I will go through a little bit after that. Optical Power Expert. So this is my optical power meter. We have as well here an interesting device, which is the PON power meter. We will see the differences between them. Why is it important to know which one and where to use which one, and to see which one of these ones are the more efficient one. We have our OTDR, which is in this case it's a Max 700 series. We have our kit of insertion loss measurement. So two test sets, one works as a power meter, the other one works as a light source, and then we have our EX1 for measuring upper layers of the OZ model. So the question for the answer for my question is, yeah, well, actually it depends. The instrument will always depend on which sector of the network are you using with, and the work that you want to do. So we will start by seeing some of these cases, and let's go to the case scenario where you want to characterize your network. You're doing the build, you're doing a new link, you have a circuit to migrate for another link. So how can I characterize my network? And the answer for that is the ITU T G650.3 spec. So this is the spec for single mode, and this is where you can find all the recommendations agreed by the operators on how to test the network. And normally I say fiber is fiber, and it doesn't matter if it is for the WDM, if it is for FTTH. So they will need to be always tested and verified that they are according to the test manufacturing test specs from the fiber supplier. So let's go for the first equipment, which is the insertion loss or optical line test set. And how can it be used? So the insertion loss measurement, the bidirectional, is one of the recommendations from the ITU T. So as part of the recommendation, as part of the standard, what is recommended is to have always bidirectional measurement where you can inject, for example, the light here on the point A, and then all the light will go to the point B, and the measurement from these 2 points will give you what is the loss, what is the attenuation on your signal, and what is your path. This is the equipment that can go so through here the splitter. It can be used from the customer house to the CO. What's the problem on this equipment? So the problem on when you use an insertion loss measurement test set is that it will not locate the fault. So if you have a break on the link, it will just tell you that you don't have power, but you will need always to use a radar or a OTDR to find out where the problem comes from and to get it repaired. So the second equipment that we have is the Max 700 series OTDR. So the Max 700 series OTDR is, as an OTDR, you will be able to send a pulse of light. The pulse of light will travel, it will hit the end of the fiber, and then the reflection back will be read by the OTDR, and will give you a graphic view, which is normally a trace, an OTDR trace. So apart from the OTDR trace, you have as well other concepts, which is the IOLM, Intelligent Optical Link Mapper. So the Intelligent Optical Mapper, we will see a little bit, we'll talk just about it later on, but it will characterize and associate the trace to a different elements using a multipulse approach, which will basically be much more accurate than the OTDR. And it will identify with reduced attenuation dead zones correctly what is the real loss of the element. So Here, just to mention, there is two different ports normally seen on the OTDR, and for whoever is on the field, there is always a difference between them. So one is mainly used for construction, which will be 1310, 1550. You always need two ports or two wavelengths for detecting elements like macrobands. So good practice, you can use the three. So you can use 1310, 1550, and one of these ports, and then you will do your tests, your installation tests, commission tests in 3-band way. And our device will be able to combine them and give you one SOR trace. Then there is these ports which are dedicated for troubleshooting, 1625, 1650. So why are these ports dedicated to troubleshoot? Well, the answer is that you have these ports away from the transmission band. So they will not, for example, they will not make the PON going down, so the OLT will not see it because it's a filtered port, and it will not interfere with the other customers on our network. So what are a few installation challenge? I mentioned that we should always use two wavelengths to detect macrobands. And what's a macroband? So macroband is where we see, so we have a light travels our fiber, and when that light hits a macroband, a curve, which is estimated in a radius, the light will go out. And this is what can be visible, and you can always find these with a red light source or a visual fault locator, as we commissioned. And they are very common on our networks, especially if you're not using fiber types like G657 and you do customer installations, residential installations, due to the tight bands, corners on our to roll the fibers in the buildings. Why is so important? So the macro bands and the detection of macro bands is extremely important, because today we work at 1550, 1310, 1490. So if you're not using RF overlay, we have the downstream and upstream, which is inside of this band. But tomorrow, with the new applications coming, 10 gig PONs, new generation PONs, we will going to be working much higher. We're going to be working on the sectors of 16, just below 1625. And looking into the loss for this specific event, if we compare the loss at 1310, which would be probably 0.3, 0.5 would be 0.6, and here I have already 1 dB loss. So that means that today I may have a margin of 5 dBs. If I keep 5 macrobands on my network, tomorrow I have a margin of 0 dBs. And this is why it's so important to characterize and to identify, resolve, and fix these small day-to-day issues and challenge that we have when we install the fiber. So, faced by the OTDR, there is also a few challenges. So normally, when I do these sessions, I always start by asking, let's work with the OTDR and let's see what is the best settings. So I have an unknown link. I am in front of a link which I don't know. I don't have the diagram. What is the settings that I should use? And so what is the length of my link? So the only way to go about on these is try and experiment and see. It's a little bit of guesswork here. Is also a little bit of guesswork for how long should I take for my link, and pulse width, which is one of the most important settings on the OTDR, and one of the most difficult ones to choose. So what is the best pulse width? Should I go for a short pulse where I can go up to event 5 and then I have this noise dropping, or should I go for a medium pulse, which I can already see some events here, can see a drop, and here you have already indication that I have perhaps 2 splitters. One I can identify clearly, the other one I don't know. I can see already a big drop, then I can see my end of the fiber here, but it's still noisy. Or should I go for a long pulse where I have my attenuation dB per kilometers on the fiber? but I don't have the events. I don't have definition. I cannot measure these events. I have here an accumulated merge events. Well, the solution is IOLM. So IOLM is, first of all, it requires minimum setup, but it saves all the time in terms of on how to measure the fiber. So, and here, when Exfo brought into the market IOLM with the multi-pulse technology, it just saved the time, not only for the people that are already proficient with the OTDR, but also saves the time when people are new and are brought into the market of fiber installation, FTTH, and not will have only the trace, but it will have a meaningful event table, which will point for which elements are faulty. It doesn't need to have the guesswork done. It will not need to investigate which pulse is the better one to use. And it will clearly identify which elements are causing the issue. And we have here macro bands, our macro bands on the network. If I tap on the splice, I can see, for example, make sure that the fiber is properly spliced. The loss could be due to a roll reflectance APC connector. And when we're talking about losses of 1/32, and I mentioned that 1/2 is minus 3 dB. So if you go 1/32, we're talking about massive losses, 16, 18 dB. So it's really important to have the correct settings. Otherwise, on the OTDR, you would not be able to go through unless you're using the IOLM Intelligent Optical Link Mapper. So we need to go. Let's go to the next level of troubleshooting. We've seen the OTDR, we've seen the IOLM, we've seen how we can characterize the network. So we will leave a little bit the characterization behind, and now we're going to focus on how can we troubleshoot, how can we make sure that we have the correct levels when installing power levels when installing the network. So the PON power meter is the instrument that will allow you to measure what is your PON power on your network. Can you use a normal power meter? Well, you can use a normal power meter. The difference is when you are using when you have a coexistence of different networks like GPON, XGS-PON, all the other ones that I refer previously, you will need to choose correctly your settings. And if you use a PON power meter, which is filtered and specially designed for PONs, you will have, no matter who you send to do the measurements, you will have always the correct readings coming in the field. So not only will give you the possibility to know, troubleshoot correctly, you will make sure that also people are using automatically the correct settings, which are embedded into the software, into the unit and filtered. So the PON power meter uses a technology called PON Aware, developed by Exfo, and is also able to give you the pass and fail status on the network being tested. And with the PON power meter, where you have your port comes from the OLT coming into the unit and ONT going into the unit, you have as well your VFL port, which can give you some possibility to detect some macro bands inside of the customer house. These can be used just before the customer house, just before the drop, and also can be used in the customer house just before the ONT. If you don't need to measure the upstream layer, you can always only measure the downstream layer, so the downstream from the OLT, so disregarding the ONT side. Why is so important to so as I mentioned, if you don't have the signal coming from the OLT to the ONT, the signal that comes at 1490, the ONT will never transmit the signal back, or you're just gonna not keep the signal active for how long due to the specification of the PON. So what our PON power meter does, it just uses identifies what is the silent time, what is the burst time and just measures this small frame that happens on a burst mode on our network. So and this is why you have the capacity, the possibility of measuring not only the downstream but also the upstream signal. You would not be able to do this with a normal power meter. So sometimes we go for a troubleshooting, and the customer just tells us, well, my internet is very slow. What is the problem? Can you fix it? Well, which equipment should I use in this case? So for the case scenario of the internet being slow, the instrument that I should use is an instrument that allows me to go on different layers of the network. So moving from the physical layer already to layer 2, 3, and 4 of the network. So and the answer for this question is the EX1. So the EX1 is the equipment that allow you to plug. So there is different possibilities. You can plug an RJ45 into the unit. You could do the measurements with a Wi-Fi. You can connect SFP if needed, or you can connect your fiber into the unit and do the measurements directly on the fiber level as it was an ONT. So where can I use this unit? So well, you can use this unit very close to the router at customer house, as you can use just on the entrance of the premises if you're using the fourth feature that we have here. So let's see a little bit in more detail. So let's go for the standard broadband installation. Just after the installation, you have a signal that comes from the OLT, goes to the splitter, and then the splitter goes to the house, goes to the ONT. So first of all, the technician, the engineer installed the router. It does a gigabit connection test, and then it does a Wi-Fi signal through the house. So this will allow not only you to know that the ONT is really well installed, but also is going to make sure that the customer is receiving the broadband signal that is contracting from the operator. If you detect any fault at this point in time being different, so you know that the routers and the Wi-Fi routers, they have different channels, and sometimes if you live in the building with different neighbors, so they will have their own channel. So sometimes adjusting the channel is really important to maximize the Wi-Fi signal at our homes. So in this case, the EX1 is the perfect equipment to do these adjustments and to do these measurements, and also to give the customer, if required, a certificate. So you can, in the end of the test, produce a certificate, a test result certificate. So if you have a big house or a big building, enterprise building, also the EX1 allows you to go to the location A that we have here near the router, and do recommendations for the customer. So you can do the acquisition on near the router, go to the rooftop, just do another measurement, check on the house, and perhaps you can always advise the customer that he needs to place one more router, or he needs a more powerful router to be contracted for the service that he wants to pretend. So not only gives you the feedback that the service is well installed, but also gives it the information if more hotspots are needed in the customer house. And the way it works, so if you look into the Wi-Fi signal, it will spread, but some of the divisions at the home will not be able to be picked. So it's a very light device, it's portable, it has autonomy battery, and you can just easily move it around the house. And because you can connect it with your through your mobile phone, you can leave it remotely and run the tests remotely. So here we have just the application that I was mentioning. So you can, as you can place and leave up to the range of the Bluetooth, you would have could run the test from the mobile app. And by doing these, you just need to select which service you want. It will run an Ookla speed test. And once it's run, the OCLA and the data rate speed test, you can just create a PDF and archive them, or just send to your customer, to your operators, stating that the test was performed on that day. You have the latency, for example. You have the speed, MAC address, and other information that may be relevant for your customer. Also, it's approved by Exfo, so that shows the quality of the test that you've done on your network. So the next question is for all of you that are doing the customer installation, doing troubleshooting, that have perhaps a power meter, or that are involved in massive rollouts, and you will see these massive rollouts coming on 5G, where the fiber expansion will be 100 times bigger than for 4G if you compare a cell site. The question is, can I be efficient and cost effective in terms of equipment? Well, yeah, there are test equipment that are not characterization test equipment, like the OTDR and like the IOLM test sets that we've seen, or like the insertion loss measurement, but allows you to use the same technology without providing, for example, an SOR trace or the IOLM panel. And that equipment is the OX1. So the OX1 can be used in different sectors of the network, can be used for point to multipoint up to the splitter. So it is able to detect any faults that you may have on the network. In this case, if you have a faulty ONT, it will just flag where the fault comes from. But also is able to be used on point-to-point metro networks, for example, or point-to-point installations, because the range can go up to 40 kilometers. Which is most of the cases enough for a troubleshooting result. Let's see how the OX1, or what OX1 stands for. So OX1 is Optical Explorer 1, and this is an equipment that we brought to the market very recently. It's not an OTDR, as I mentioned, is not a power meter. It stays in between. Is a new category which we called optical fiber multimeter. And a few of the features that he brings into the market is it has a light source, so you can inject light into the fiber, and if you have a live fiber detector to detect where are the tone on the fiber, you can do that for the data centers, for example. It has a power checker functionalities. It has a flash advisor. And the flash advisor is what you have here present on the screen. So I will run into detail a little bit more on this with my demo, because I have here an OX1. Your time is precious, so a really good functionality is the Fault Explorer. Not only gives me the information if the link is good or bad, but also points me for any faults that I may have on the network. Then we have the third mode, which is the link mapper. And the link mapper will flag all the elements on the network, especially, for example, if you want to remove a patch of fiber, you can see how long it is. For example, if you're working to remove a 2 meters patch cord or 10 meters and you don't know where is it ending or how long it would be. Besides verifying insertion loss and ORL. So it will have the same, it's going to be the same technology as we use on the IOLM. Another feature that this element brings into the market is just the replaceable connector. So sometimes we see connectors or OTDRs being brought into our repair center with damaged connectors. The customer spends 2 weeks without the unit, so that decreases the revenue. And this is almost equipment which is maintenance free. So the idea is for the customer to do all the operations, replace itself. It brings as well 3 years warranty. 10 years calibration, so it's the cost of ownership is almost unmatched for anything in between. So just here you have a small summary table of what the element is and what is the settings that you have on the element. So in terms of tests, display, length, insertion loss, ORL. So this is can be used on both. So if you want to have faults and explore the faults when necessary, if I go to the customer house, then modes like the Fault Explorer, Link Mapper will be the ones that you want to use. If you want to detect all the elements, so Link Mapper, just a summary table. With the unit, we also brought the XFO Advisor. So, and the XFO Advisor relates to what good looks like. So is 6.4 kilometers, almost 6.4 kilometers, with a loss of 3.7 and an ORL of 38.3 good or bad? So if I have a pass or fail, which I can still have, that would tell me that I'm failing the thresholds that I manually set. But if I don't have the threshold set up, XFO with the XFO Advisor and the rating of 1 to 5 stars will pinpoint me and tell me, well, this is good, this is not good, I can improve this for sure. So other tools, as I told, so power, loss, fiber tracing. I will go for the demo, and I can quickly show you on the next. So the setup that I have. So first of all, it's always important. So it's always important for us to have in attention that we should always inspect our fibers. So, and our products like the fiber inspection probe, they are really interesting, and they always make sure that. And here I have it connected to my mobile, but if I don't have our fibers clean on our networks, when I go for high data rates, there will be we were going to have always problems on the fibers, and it doesn't take long to inspect the connector. As you see here, just a few seconds, and we would have the acquisition. We can be able to run the analysis, and I will have at least a pass or fail result, not only on the unit, on the fiber inspection probe, but I also going to have, so I'm able to see if my connector is clean or dirty in just a few seconds. So in terms of OX1, I will run through the modes that we have. So the first mode is the Flash Advisor. So Flash Advisor not only gives the indication according to the XFO Advisor rates, but also is extremely quick. So if I want to do a validation of 144 fibers, the time that I will take will be 3 seconds per fiber. This is how quick we can be in measuring the length, the loss, and the ORL. And it doesn't matter how many kilometers do I have, it will be always 3 seconds. Here I have just my setup is only a small link, so it's 17 kilometers. I have 8.2 dB loss. So I want to know, and my question is now, I want to know why I don't have these 2 stars colored. So where are my problems on the link? So this is where I go for the next mode, which is the Fault Explorer. So if I want to know a little bit more of the link, I want to repair the fault. So you're gonna go for the Fault Explorer. For the Fault Explorer, the target time will be 5 seconds, but this will depend on the link element numbers. So the software will spend a little bit more time trying to understand where the fault comes from. So on this mode, you already start seeing here the element windows. And I can see already that my unit already spotted 4 elements. So it's still running the test, so it's going to spend a little bit more time trying to understand if I have a little bit more impact. I can see it already so I can see already here the red mark as I have an element which is a fault. So the unit uses Bluetooth. So just a little bit in regards to the unit, uses Bluetooth. It gives me the indication the laser is on top. And once it's completed, I have my fail, the pass or fail result here on the top. I have my unit detected a fault. I'm just going to go scroll to see how many faults. So I have looks to be a splice. So here I have a splice. I have my end of the link, so at 17.2. 30.6, I have another splice, meters, and I have here this element, which is a macro band. So as we've seen on the IOLM, using the technology link aware, so we would be able to detect these elements and correlate. So as I explained before, the macro band is detected when you have a different loss at 1310 and at 1550, at least 2 wavelengths to correlate. As you see here, my splice loss is inside of the limit for 1310. My macro band loss at 1310 is inside of the limit. However, if I'm using a signal at 1550 nanometers, it will be heavily impacted for almost 1.2 dB more than at 1310. So if I want to go, I can go as well for the splices. I can see where is it failing in detail, and it gives me the indication. So if I want to go to the connector as well, so I don't have the connector on the loss. And here is interesting so as well. Why don't I have the connector loss to the end? Well, for those of you that work with your TDR, you know that if you want to characterize the last connector, you need always to use a receive fiber on the other end, and that's the only way you would be able to characterize the loss on the connector. So going back, let's explore the third mode, and the third mode is the link mapper, and we've seen here, so in this mode is going to take a little bit longer than the fault explorer, but here the idea is not to flag only what is fault, but also to flag all the elements, all the splices that are all the connectors, and give the indication, for example, that how many elements your link have, and if you want to remove a section of fiber, how many meters you will need to replace, or where can you access, or where is your joints on the network. So it gives you a little bit of choice on how to use this mode. So by the time that it's doing the test, I can explain you this is the new connector. So this is where this is the pluggable connector, which goes here on the top. So you see that it just slides in. So it would be push in connector, click out connector. It's something that you can replace in the field. So you can have a set of units, can have a few these one spares, and it will be a customer replaceable thing. The battery as well. So parts from the autonomy, the manual, the instruction manual allow you to repair the battery in case of needed, as well reducing the ownership cost. There are different OX ones. So in this one, I have the installation one, which is the 1310-1550. You may have the 1310-1550 and 1650 on one single unit, or you may get the 1650 nanometers only maintenance one. Okay, so our test is almost completed. I can see here that instead of the first 5 elements, now I have 6 elements. And these 6 elements, that means that one of these ones is not a fail, but it's just been detected. So is this splice. So this splice is a splice, but is green and is detected as a good splice. We don't want people to replace connectors in the field without checking. So there are a few. So even with the unit, we can see that we have, if you go to the measurements, so it will archive the measurements, but if you go for the settings, you would go and we have here optical output diagnostics. So this is also a really important feature that we brought, and I didn't mention, but this unit has a few patents on it, and in this mode, they're just going to tell you, well, I will check your link. So what is the connector that you have linked? So I just select it, and it will just do the test on my launch lead, making sure that I have the right ORL and the right loss. Meantime, I'm doing this so I can access the results. So if I want to access the results, I can always use my mobile app. So I'm here connected into my mobile phone, and I can on the go do a PDF report where I can put the job ID, and I can do create. And in this case, it will create a job report as soon as I leave the customer house, and I don't need to do the post-processing needed. So here you have, so this will be a report completed where you can have the fiber length, the link, and any identifier that you think it's interesting for you to have. So I will stop the demo and I go a bit for the presentation again, and we will see how can we join both features in one go. So the last case scenario that I have to present you is when you go to the customer house and the performance measured does not meet the expectations. So what could it be? So in this step, we already installed the network. The customer has been happy for a while, but now we don't have, so we lost the internet connection. So the first thing that we could use is actually start using the EX1, and we're going to use the EX1 with a GPON stick, which we're going to replace the OLT, the ONT, and in this case, by replacing the ONT, we are already discarding any problems related with the hardware. And if we have this case scenario where we have a fault, which is just the unit is measuring minus 30 dB, so the power is very low. We know that normally is around, can be up to neg 28 dB, so maximum, that's what I've been seeing in the field. So this already proves actually that the ONT is good, but my problem comes from the fiber. So how can I troubleshoot that? Well, I'm actually detected that I have a cable tie near the splitter, which is pinching my fiber. So this is how do I know this, where this problem is? So let's imagine that we have the second case. Let's imagine that we have a connector which is not properly connected, and is also maybe one of the case scenarios where my signal is being lost. So, and the answer now, which equipment shall I use, is the OX1. So the OX1 with the capabilities that we've seen will be the ideal pair with the X1 to be used on this case scenario. So I can drop the OX1 into the fiber and check just before the splitter if where my problems are. And by saying that, I will be able to identify misalignment in the connectors, macro bands, as you've seen, and repair them. So, what are other problems that we may see as well? So again, with the OX1, I will be able to detect high losses on the connectors, like I have here. That will pinpoint me perhaps for a dirty fiber, a dirty connector. And with that dirty fiber, using, for example, a FIP, I will be able to replay, to clean, make sure that everything is clean before plugging back on, and I will be able to reestablish the link and make sure that the customer have the right connection, the right broadband. And so not everything is so before, after doing the characterization, after doing the network, is always important to have the right documentation in place, to have the correct standards of documentation archiving the results. And with these, with TestFlow and with Fast Reporter, they become very useful in terms of not only checking SOR traces, IOLM traces, insertion loss measurement traces with the report, doing the reporting it and checking that the result after on post processing has been done correctly. But also TestFlow, which I strongly, we don't have time to do today to speak on TestFlow, but TestFlow has been as well a powerful tool when we want to upload the results into the cloud. So it's a cloud-based software which allows you to do the tests on the platforms and all the results being uploaded automatically without the need of using USBs or any other or email to transfer data between you and the operators, or even between your teams of 4 or 5 engineers. So I welcome any questions that you may have in regards to the session of today.
Alright, thank you, Nuna. Så hvis der er nogen, der har spørgsmål, så kan I stille dem nu, enten til Nuno eller mig. Og ellers så vil jeg lige hurtigt opsummere lige den sidste times tid her. Altså, det som vi startede med at kigge lidt på, det var de forskellige PON teknologier, selvfølgelig også punkt til punkt, som er den her forholdsvis simple infrastruktur. Jeg bruger mange fiber, men hver kunde har sin egen fiber. Men derfra til de forskellige PON, som GPON, som der er mange, der ruller ud i øjeblikket, til XGS-PON, som Nuno nævnte, og så de her Next Generation PON løsninger, som kører med mange forskellige VDM-bølgelængder. Og det som hans konklusion og budskab egentlig er, det er, at man kan faktisk godt have et glimrende GPON-netværk infrastruktur lige nu. Men lige så snart man skal opgradere til XGS eller Next Generation PON i fremtiden, så kan det faktisk godt være, at ens installation ikke er lige så god, som man egentlig havde regnet med, fordi de høje bølgelængder, som de nye PON-løsninger kører på, er mere overfølsomme over for bug specielt. Og så kan det godt være lige pludselig, at tingene ikke virker, som man ønsker. Så derfor allerede nu er det vigtigt, selvom det kun er GPON, man ruller ud, for at fremtidssikre, at man kan opgradere hastighederne og båndbredden, og få kontrolleret med det samme, med de forskellige instrumenter, som vi har gennemgået i dag, at installationen også kan klare en fremtidig PON-løsning. Og fra at kigge på de her forskellige PON-teknologier, har vi snakket IOLM, den her patenterede OTDR-løsning fra Expo, som skyder den her dynamiske multipuls, så giver jeg et first time right resultat med alle elementerne, som splitninger, connector-samlinger, book og også splitter praktisering, som gør det nemmere at finde ud af, hvor er fejlen helt præcist henne. Fra IOLM til det nye PON-parameter, eller det nyeste PON-parameter, som vi har en del kunder, der allerede begyndt at bruge, fordi jeg ved i hvert fald også, at de kigger ind i XGS PON. Til EX1'eren, den her lille speedtester, som vi også har en del af derude. Jeg håber, I kan se nytten, det nyttige ved den. Speedtest på kunden, der er ofte, eller jeg ved ikke hvor ofte, men der er i hvert fald, jeg hører om nogen, der ringer ind og brokkes over deres hastighed på internettet. Og der kan EX1'eren altså gå ud og sige, prøv at høre, du har den her reelle hastighed, så måske er det deres computer, der har et dårligt netkort eller andet i den retning. Du kan lave wifi test i huset, og du kan også bruge den direkte på fiberen, som du nu viste. Den nye OX1 Optical Explorer med en lille demonstration her mod slutningen. Fantastisk værktøj, barometer indbygget, lyskilde indbygget, og så er de her fejlfindingsmuligheder, som kan give dig alt fra 5 stjerner til pass fail i henhold til dine egen thresholds. Et virkelig stærkt værktøj, som vi også ser stor interesse for. Og som jeg sagde sidst, jeg har demoenheder, så har I lyst til at prøve den af, så kontakt mig. Min mail og mit telefonnummer står på skærmen, hvis I ikke allerede har det selvfølgelig. Og ellers så håber jeg, at I har fået noget ud af den her sidste times tid. Det er nu, I kan stille spørgsmål. Jeg tiger lige stille i 5 sekunder, så har jeg mulighed for at byde ind. Og ellers så er det bare, jeg tror, at Nuno han har været rigtig grundig igennem det her, siden der ikke er nogen, der har nogle spørgsmål. Og så ellers vil jeg bare sige mange tak, fordi I kiggede med.